Alright, so here's the video key for the test review. So it says match the following polynomials with their classifications. So the first one, A, it says we're looking for a second degree or quadratic trinomial. So trinomial is talking about three terms, right? So we're looking for the highest degree of 2 with 3 terms in it. Well, there's only one with 3 terms, and it's right here. It does have a highest degree of 2, so that would be A. The next one says fifth degree monomial. Monomial is counting for 1 term. Alright, so fifth degree means highest degree is 5. So here's a fifth degree, and it only is 1 term. So then that's letter B. So we got A and B done. C is asking for linear binomial. Binomial meaning 2 terms. Linear means that it has an first degree. So we're looking for 2 terms with a first degree. Here's 2 terms here, but that's second degree. So we got 2 terms with a first degree. So this is technically a 1 right here. So there it is. That's C. D says second degree binomial. Well, we just saw that one. That was 6. Third degree cubic polynomial would be third degree. Polynomial means many or multiple. Right, basically larger than 3. So third degree, more than 3 would be right there. There's a ton of terms on that one, so that's our third degree polynomial. And then 0 degree monomial, so the only other monomial is number 3, and that doesn't have an x on it, so it's 0 degree. 7 says circle the answer that is the y-intercept of this equation. Well, hopefully you remember that the y-intercept is always just the c value. The harder part here is remembering that when you write the y-intercept, the x value is 0, the y-intercept is the y value. So 0, -5, so we're looking for that one, and that one is B. It says check all of the following equations have a vertex that is a maximum. So we're looking for, maximum, this says minimum. So we're looking for all of the ones that are opening up, because then the vertex would be down here for a minimum. Ones that open up have an a value that is greater than 0, meaning that they're positive, so a value is positive. So then the ones with positive a values would be y equals x squared, and y equals x squared minus 4x minus 5. Those are our two ones that are opening up and have minimums for vertices or vertexes. Given the graph to the right, identify all of the key characteristics below. So it asks for the axis of symmetry. Remember, that is the vertical line that just goes straight through the middle of any quadratic parabola. So that vertical line is at x equals 1, so our axis of symmetry is x equals 1. Coordinates of the vertex here, vertex is always either that highest point or lowest point. In this case, we always use the axis of symmetry as the x value, so 1. And then the y value in this one is 8, so we're 1, 8, and it is a maximum because the graph is opening down. That is the highest point of this graph. Coordinate of the y-intercept, we're looking where we cross the y-axis, and that would be right here at 6, so then we're 0, 6. Our x-intercepts are where we're crossing the x-axis, so right here at -1, right here at +3. How you write these, it's the x value, so -1, 0, and +3, 0. That's how you write x-intercepts. Domain is always all real numbers for our quadratics. And for the range, the highest point for the range here is this 8. That's the highest possible y value. So all of our y's are either less than or equal to the number 8. And we're talking y's because the range is all of the possible y values. Alrighty. Next up, quadratic formula. So I know you guys are dying to hear me sing the quadratic formula again, so here it is. It goes x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. And that is how you do the quadratic formula. All right, it needs to be memorized for the test. Make sure you get it down. So let's go through and look at 10. The a value, well, there isn't a number here. We know that that's a 1, though. So we have 1. The b value is the middle term, so negative 8. And the c value is the term without the x on it, so that's negative 20. And then we physically just plug that into our quadratic equation. So it starts with x equals, and then we go negative b, so negative, and then negative 8, because that's what b is. So we plug that in right here. And then it's plus or minus the square root of. B squared would be negative 8 squared. And then minus 4 times a, which is 1, times c, which is negative 20. And that's all divided by 2 times a, which is 1. So then let's go through and do some simplification. Negative 8 is going to make positive 8. And then that's plus or minus the square root of. Negative 8 squared is 64. And then negative 4 times 1 is negative 4. Negative 4 times negative 20 would be positive 80. And then 2 times 1 gives us 2 in the bottom. Continuing, we have 8 plus or minus. This is the square root of. 64 plus 80 is 144 over 2. 8 plus or minus the square root of 144 is 12. You can check that on your calculator if you'd like. And then that's all divided by 2. And now we need to split it up into its two cases. So one is 8 plus 12, all divided by 2. The other one is 8 minus 12, all divided by 2. 8 plus 12 is 20, divided by 2, which gives us 10. 8 minus 12 is negative 4 over 2, right? Is that negative 4? Yep. And negative 4 divided by 2 is negative 2. All right, so there's our two answers for that quadratic equation. Okay, let's take a look at the next one. So, number 11, our a value is negative 2, our b value, positive 7, and our c value is 9. And then from here, we're going to go x equals the opposite of b, so negative 7. And then it's plus or minus the square root of. B squared would be 7 squared, minus 4 times a, which is negative 2, times c, which is 9. And then all of that is divided by 2 multiplied by a, which is negative 2 in this case. So then we have negative 7 plus or minus the square root of. This is 49. Negative 4 times negative 2 is positive 8. 8 times 9 is positive 72. And then that's over negative 4. So then we have negative 7 plus or minus, this is the square root of. 49 plus 72 gives us 121. And that's all divided by negative 4. Square root of 121 is 11. So this is negative 7 plus or minus 11, all divided by negative 4. And then you split it up into its two cases. Negative 7 plus 11 divided by negative 4. Negative 7 minus 11 divided by negative 4. Negative 7 plus 11 would be 4, right? So positive 4 over negative 4, which gives us negative 1. And then negative 7 minus 11 would be negative 18 over negative 4, which both of those are divisible by 2. So we're going positive 9 over 2 because the negatives cancel. So it's all positive. All right? And that's how we use the quadratic formula. Last but not least, we have number 12 here. It says, answer the following questions to help graph the function. So list A, B, and C in here. So A is going to be this negative, so negative 1. The B value, we have negative 2. And the C value, positive 8. It says show work and find the x-intercepts using the quadratic formula. So again, we have x equals the opposite of b, so negative of negative 1, and then plus or minus square root, b squared, it's the opposite of b. Hopefully you caught that, right? Should be negative negative 2, plus or minus the square root of b squared, so negative 2 squared, and then that's minus 4 times a, which a is negative 1, times c, which is 8, and then all of this is divided by 2 multiplied by a, which is negative 1. So then now we need to simplify this, right? So negative 2 is positive 2, plus or minus the square root of. Negative 2 squared is 4. Negative 4 times negative 1 is positive 4, times 8 is positive 32. All of that is divided by 2 times negative 1, which would be negative 2. Okay? From this point, we have 2 plus or minus square root. 4 plus 32 is 36 over negative 2. Square root of 36 is 6, so this is equal to 2 plus or minus 6 over negative 2. And now we split it into the two cases. So that's 2 plus 6 over negative 2, and that's 2 minus 6 over negative 2. 2 plus 6 is 8 over negative 2, which gives us negative 4. 2 minus 6 is negative 4 over negative 2, which gives us positive 2. So what do we do with those x-intercepts? Well, we write them here. This is negative 4 comma 0, and the other one is 2 comma 0. We can also fill that into our table, right? So it doesn't matter where, we just say negative 4 and 0, and we have 2 and 0. And then let's plot those. So negative 4, 0, and 2, 0 would be those 2 points. Now we need to find the axis of symmetry. Axis of symmetry always uses the formula negative b divided by 2 times a. Another great way to find the axis of symmetry, guys, if you don't remember the formula, is look at those x-intercepts. The direct middle of your x-intercepts is the axis of symmetry. So the distance between them is 1, 2, 3, 4, 5, 6. So then if we go 1, 2, 3, this would be the middle right here. So then our axis of symmetry is right here, negative 1. All right? So kind of neat, that direct middle. If you want to also see it mathematically, right, axis of symmetry is negative b, which would be negative 2, over 2 times a, which is negative 1. So that gives you positive 2 over negative 2, which gives you negative 1. And we write the axis of symmetry as x equals negative 1. How do we find the vertex from there? We plug in whatever you get for the axis of symmetry into the equation. So this is y is equal to negative 1 squared minus 2 times negative 1 plus 8. So that's negative 1, because negative 1 squared is positive 1. Negative 2 times negative 1 is positive 2 plus 8. Negative 1 plus 2 makes positive 1 plus 8, so then we get 9. And there's another, this is a y value, this is an x value, so we say negative 1 comma 9. And then we can put that into our table, negative 1 comma 9. We can also plot it, right? Negative 1 up 9 would be right here at this point. And now we're almost done. The last thing we need to talk about to finish filling in this table is the y-intercept, which we will in a second. This is a maximum. We know that because from this vertex, we're going to be opening down towards the x-intercepts. So we know that's a maximum. The coordinate of the y-intercept, hopefully you remember this, right? It's our c value. C value is 8. So it would be 0, 8. And we can add that to our table, 0, 8, and then plot it on the graph. 0, 8. And then to find that very last point, you just reflect that y-intercept across the axis of symmetry. So 1 away, we reflect it over 1, which puts us right here. And there's the graph. So we just say that last point in the table, which is negative 2, positive 8. So negative 2, positive 8. And now we have enough to graph this graph, right? So we're going down like this, and then down like this on the other side. All right, there's our graph. Speaking of domain, right, domain is always all real numbers. The range in this case, y is going to be smaller than that 9 value right there. So y is less than or equal to 9. Okay, so a lot of work for question number 12, but it kind of just goes right in order there, right? You find You use the quadratic formula to find the x-intercepts, and then you graph them, right? After that, you find the axis of symmetry, either using the x-intercepts or using the formula, right? And then after that, you find the coordinate of the vertex by plugging in the axis of symmetry into the equation. And then the final thing you have to do is you just have to find what the y-intercept is, okay? Once you know the y-intercept, then you can just find that last point with a reflection across the axis of symmetry. So, if you have any questions, please message me on Canvas. We need to have a good grade here on this upcoming test, guys. So, hope you have a great day, and make sure you're studying.